Hi, my name is Krisha and I'm here to teach you about combinations. So what are combinations? Combinations are just an easy way to count how many different items that can be arranged. One important thing to remember about combinations is that the order does not matter. The order is something that you can put in any way that you'd like. You can put one value in one place and then another value in another place. Or you can completely change them around and it'll still come out to be the same. Another important thing to remember is that replacement is not allowed. You can't use one number and then put it back into the original set, the original data set to use again, because that's not how combinations work. Each number can only be used one time, but the order is not important. So the notation for combinations is pretty simple. It only has two values. The first one is n, and n is the total number of different items that are available. So it's the total amount of numbers that you have to choose from. And then r is the number of items that you want to be chosen. So r is just the number of slots that you have. It's the number of it's the number of slots that you have to fill so that you can, an important rule about combinations and permutations is the factorial rule. And the factorial rule is just the product of decreasing positive whole numbers. And one example of the factorial rule would be 3 factorial, which is 3 times 2 times 1, and since 3 times 2 is 6, and 6 times 1 is 6, 3 factorial is 6. So how do you tell if it's a combination versus a permutation problem? There are 3 simple ways to decipher whether or not it is a combination or a permutation problem. The first way is that there are n number of different items available as a set, and then you have to be able to take r out of n. So again, n is the whole number, and then you have to take r out of that whole number, so it's the number of slots that are available. And how you tell the difference between a combination or a permutation problem is the rearrangements of the items don't matter. Like I said before, order isn't important, so you can put them in any way that you want and you will still come out with a combination problem. If the order does matter, then it's a permutation problem. Like for example, your days of months of the year, presidents in history, or days of the month, just something that has a specific order to it is a permutation problem. But we're dealing with combinations, so we don't have to deal with that. An example numerically of the combinations is, say you have 3 slots to fill. You can put someone or something in slot 1, 2, and 3 and then do the problem, or you can make them, they can be in the same slots, but you can switch the slots around and make it 3, 2, 1, and it'll still come out the same. So the formula for a combination problem only has n and r in it, and it is n combination r, and so this is what shows on your calculator. But what your calculator is actually doing is n factorial over n minus r factorial times r factorial. And so for an example, say you have just won 4 tickets to Disneyland, and you are taking 1 ticket, so there's only 3 more tickets available, and you have 6 friends that want to go to Disneyland with you. So the first step is to find r and n. So r would be the total, or r would be the number of tickets available, which is 3, and then n would be the number of people that want to go, which is 6. And so what you would do is you would just plug all of that into the formula. So it would be 6 combination 3 with 6 factorial over 6 minus 3 factorial times 3 factorial. And then that comes out to 6 factorial is 720, and then 6 minus 3 is 3. So then 3 factorial, like I said before, is 6, and then again is 6. And then for the third step, still keeping 6 combination 3, it would be 720 over 36, which comes out to 20. And so then all of the different combinations of the 3 friends that can go comes out to 1 over 20. Another, another problem that is combinations is a lottery ticket. So having the same formula, which is n combination r, and then factorial over n minus r factorial times r factorial. So say you were getting a lottery ticket and you have 50 numbers to choose from, so 1 out of 50, and then you only have 5 slots that you can put those numbers in. So 50 would be the total number that you have, and then 5 would be the amount of slots that you can put these numbers in. So it would be 50 factorial over 50 minus 5 factorial times 5, and that would come out to 2,118,760. And then, so then the probability of winning that lottery would be 1 over 2,118,760, which comes out to 0.00000047. And that is combinations.